Okay, so we continue. Okay, our power electron device. Okay, so today we should be able to finish this chapter. Okay, we have done the DIAC. Okay, last class. We also done how to create a parts. Okay, or component that not available in MATLAB. And now we're moving to the last one. Okay, the last device used, which is very rare. Okay, really rare used in converter. I only see it used in AC converter. All right. Now, okay, this one is called DIAC. Okay, as you can see in the symbol, the only difference between the DIAC and the TRIAC is that it does not have any gate. Okay, to actually enable, okay, the operation of the DIAC. So basically, it is just two diode anti-parallel, okay, connect together. That's all. All right. Now, then what is the difference? Okay, the difference is that the what we call this a forward voltage is very high. Now, as we know that our this diode, right, forward voltage 0.7, okay, high power one may be 1.2 or 1.3. But this one can be as high as 30 volt. Okay, it can be as high as 30 volt, 50 volt, and so forth. So there is no like 1 volt or 2 volt, at least 10 or 20 volt and above. So that's the only difference. Okay, so in terms of this, what we call this operation, right? Now, this is how it looks like. You need to hit, okay, their forward bias voltage so that it will turn on. When it turn on, right, it turn on at both direction. It's not like normal diode. Normal diode, right, when it turn on at 0.7 volt, it only turn on in one direction, meaning that it only allow current to pass through one direction and it blocks in the opposite direction. But for DIAC, right, once it turn on, okay, the most typical one is 30 volt, then it will turn on for both direction. Like I said, it's very rarely used, okay, in power converter, but you can still see them using in this, what we call this AC converter. Now, where do you see the operation of this is the dimmer, the light dimmer. Now, this one is very common in our house, okay, or, you know, it's one of the very common product, okay. We call light dimmer. Okay, it is very cheap. You can get them in, you know, less than 10 ringgit. Then you replace your house switches, right, with this light dimmer. You can actually control the brightness, okay, of your, what we call this, your light bulb, you know, okay. Of course, you cannot use to control fluorescent light, LEDs. It depends on the type of LED light you're using, but it is used in all this. Okay, and then the circuit, right, is very, very simple because this is considered AC converter already. Your AC in, your AC out. Okay, to turn on, you know, your, what we call this, your light. Okay, so if you look at the circuit, right, it's pretty much simple. Okay, You see, this is your light bulb, okay, and this is your triac. And for your triac, right, and of course, this is the RC circuit, okay, that will determine the phase difference. And then the output of this, right, it pass through this DIAC. Like I said, the DIAC usually used in conjunction with the triac, okay? So it will not allow any AC voltage less than the stated, okay, 50 watt, okay, 40 watt to pass through it. And then, now if you look at the data sheet of this product, okay, okay, you can see that it looks no different than ordinary diode. All right, so this one is DB3, okay, DB3 diode. And you can see that the VBO, the break over, not breakdown, break over voltage. The break over voltage is 32 volt. So meaning that you need to apply AC, okay, that is greater than 32 watts only, it will conduct current in both directions. And you can see that, yeah, the break over voltage, they have typical, okay, minimum, and then maximum. So they have a range of what we, like I say, if we have 3, right, we will take the typical, okay, we will take the typical. So the rest is just the characteristic, okay. Also, they have the power dissipation. Power dissipation information is important for you to do the thermal. Remember, you know the power dissipation. You can use the equation to calculate the temperatures. And then this one, okay, the maximum current, right, it can use, okay, is 2 amp, okay, because this is considered a very low power version of the DIAC. Okay. Okay, this is an example. And now how we're going to model it is very simple. All right. So we just use 2 diodes, like I said, anti-parallel. Connect them together. Okay. So let me just show you. Okay, I'm not showing you how to make the blocks. You guys should know how to make the blocks already. Okay, so we take these examples. Again, the AC input, okay. Okay, it's the same, 325. And then we have a diode. Now this one, you can use a normal diode, a simpler diode. Okay, so the difference is that you look at the forward voltage, you just set the forward voltage. So in this case, I set 100 volt. Okay, so make sure that the rest, you no need to set already. Okay, 100 volt. And then this one also 100 volt. That's all. Okay, and then we put a resistive load. Okay, 10 ohm. And then we just measure the current and the voltage across it. Like I said, this diode, right? In fact, the detail diode also can use. So you don't do much changes except the forward voltage. And you can find it in the SIMscape. Okay, it's the same lah. Okay, or you want to semiconductor. Okay, so the diode here. Okay, or electrical think we have another. This is a simple diode, okay? You can use this one. Okay, to test this out, right? Yeah, you run at 0.1 second, 5 cycles, and then this is what you see. You can see that, okay, when the voltage, right, is not reached up to the required voltage, which is 100 watt, so it will actually top off the bottom of the voltage, okay? It chop off. Remember the peak is 325, right? Now you can see the peak is now reduced to 225. Okay, it has been chopped off, so it becomes something like that. Okay, it becomes something like that. Now, previously tried, right? We chop off by their side, right? Or angle. Okay, or you can translate it to the time lah. You chop off by their side, but this one you chop off, okay, vertically, not horizontally. Okay, so in this case, how much you want it to chop off depend on how high is your what we call this your breakover voltage. So if I change it to a little bit higher, in fact, you look at the voltage is good enough already. You don't need to look at the current. Okay, it will look something like that now. So do you notice that it looks something like a pulse already? Okay, now this is the pulse, right? If used in this light dimmer, as we know, after this DIAC, right? What the DIAC see is a pulse, okay? It's a pulse so that it can control this, all right? To allow current to pass through in a way that it limits, okay, the power across the load here, okay, across the load here. So that is one of the application, okay, of this DIAC. So this is really a very pure analog types, okay, of the what we call this digital pulse lah, we can call it, okay, analog type or digital pulse. So it doesn't require any microcontroller, doesn't require any programming, you know, and you can do something like that. So this is really a very pure analog circuit. Okay, so I think we are almost there already lah. Okay, so I want you guys to quickly do this. Simple one. Okay, you like I said, you can remove this one to save your time. You can remove this one, just connect this one. You just need the, you know, the wattage. Okay, you just need the wattage to see this. And you all can try different voltage. 100 watt, 200, 150. And then you all can post it in the yeah, in the team chat box. Okay, you still can see the pulse. Okay, like I said, this chapter, right, we mostly introduce the component, okay, or the device. So later we move on to converter, then you can see more detail about how this switching device, all right, apply in using what we call this all sort of converter lah. This will be the last one for this chapter, okay? For you all to do this. Okay, very good. A Boon Hong, first one. Wow, skill already. Last time you are the one always told me got problem one, right? But now today you are the first one. Very good, very encouraging.
Quite similar with the last time one, the Thai as well.
Like I said lah, you know, once you did a simple one, right, the next time is easier lor. You just open the file, right, change a little bit, save another file, it become another circuit already. Oh, this one, apa ini? Why got a bit different one eh? Oh, you want to see the thing? Okay, boleh. Okay. At least you can see, you will notice the difference, right? The first time I asked you all to do, it takes a long time. Now every time I ask you all to do, you can see that your speed, you know, it is there already. So physical class, okay, you all got the result, should be pretty straightforward. Okay, this is just some thought of mine. I know that most of you would like to attend the online class, okay? I have no objection, okay? Because, you know, this is our right. But I know that, you know, this, you need to go through a proper channel to get approval to attend online. That's what I need to say. I don't know what will happen to you, you know. You see, they are trying very hard to tell you guys. Okay. And then the thing is that I see a lot of approval coming in already, which I'm very happy. But the thing is that they are a group of students. I mean, you need to get the reason, right? Try not to give a reason like that. You see, Dr. Morning class, need to bring laptop in the class to do exercise, MATLAB. Therefore, I cannot come. I don't have laptop, or my laptop battery died already. Then they got approved because of this. But slowly, a lot of people see, hey, this one more. they use the same sheet lah. So you know what will happen after this? UCSL will start asking, no, sorry, your class really need to do this on in class, eh? How should I answer? I will say no, because course online never asked me to do this, right? Then he say, okay, do not do this and don't force everyone to come back. This is what I predicted lah. Now I'm very okay with it, but who lose the knowledge? I'm teaching you out of my personal, you know. If I visit this, I'm done already, you know, this class. You see, I'm actually doing this for your own good. It's not like, now I don't get extra pay after teaching your own MATLAB. Okay, so just try, I mean, you know, who knows, right? Imagine you are the people up there to make sure students come back. And the half of the class gives this reason. You know, then they will see, they will check one and say, okay, Wk4.2 course online. Man, no right? No man in class, right? Okay, cannot do this. Wow. Okay? I mean, there are lots of reasons you all can use out, but don't take this reason now. So another thing I want to share is that if you follow a traditional textbook, okay, if you follow a traditional textbook for this particular chapter I'm teaching right now, this is how it looks like. Okay. Okay, textbook, latest edition, right? This is a textbook for Power E, very famous, okay? And then if we look at our chapter here, where is it? Okay, power transistor, 155 page. Okay, typical textbook, power transistor. Okay, starting to tell you what is transistor, and a lot of words, okay, and a lot of words is basically what I say in the class, but in a much more simplified words that you all to get you all better understand. And then again, a lot of words, a lot of words, and then try to show you this, which I have shown you in my slide, right? And then another diagram, okay, the IV curve, like I say, the textbook standard transfer curve, okay, some equation, how it works, equation, that's all. Okay, up to this point, never show data sheet, never show how to really model what you want to use this in real world. No. And then never explain why data sheet looks so different from here also. No, it yourself. Okay. And then next one, switching characteristic. Okay, remember the switching? It tells the switching thing by the very old school way of circuit. It explain the circuit. Remember the circuit I see? You see the one I provide, I split them into pieces. You can see the rise time, delay time, whatever time, right? They throw you this diagram, imagine yourself. Okay? And then try to explain the switching in the semiconductor way, which is at the chip level, which I don't think is necessary, right? We are all doing applications. So they explain the curve in the very detailed zoom in, okay? But never explain the rest. Delay time, whatever, you just say this is the right time, that's all, you know? And then again, try to explain the switching for the junction field effect transistor, which we will almost never use it anymore. And then a lot of words, I have been in this teaching and research for over 20 years. I never use it, I would say. Okay. That's why a lot of students, they sometimes graduate, they say, why the university is teaching me something that I never use in my engineering life, you know. Yeah, if you follow textbook, that is what happened. Okay, you see a lot of redundant thing. Tong, 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 you see? Okay, now only you talk characteristic, but never tell you how to model in real life and in the what we call MATLAB. Okay, equation, example. Okay, come back to the switching again. Okay, this is the example of the switching I show in the class. Of course, I never follow this one. I follow the one much more practical. And this is only the two diagram it show. I combine these two together and split them into pieces so that you all can better understand and the calculation. All right. And then remember this one? I purposely did a program to show you how this works, right? And this one, they just draw, say, okay, you imagine yourself. It never relates them. Remember, my program relate these two and the switching. Okay, and then a lot of words. Again, semiconductor, IGBT. Okay, this one, I don't see even used in the real power converter. Okay, and a list of table of the different of symbols. You see, to me, symbols, right, usually is pretty standard, right? But the most important is, I rather show this symbol, I show the symbols different that used in MATLAB, so you know which one is which one. Okay, symbols again, switching, okay. And then they talk about SPICE model. They did talk model, but they use SPICE model. Okay. MOSFET SPICE model, but we are not using P-SPICE. If you are using P-SPICE, you can do the same. Okay, so they talk about SPICE model. Okay, and then I think, yeah, almost a lot of not relevant things in this chapter. Okay, summary done. You see, it used almost 80 pages talk about transistor. It seems a lot, right? But the real information that is useful is actually very little. Okay, and you can see there's no thermal. No explain about thermal at all, right? You can hit until 120 degree, 30, 200, don't care. They don't care about this. So that's the problem, okay? That's why I will try to summarize and extract those important information, okay? Relevant, what I say information is relevant information. So to make it much more lively, okay, for you all to learn. But of course, if you have time, you want to learn more, you are most welcome to get the books and start reading it. Okay, let's see. All right. Okay. Okay lah, this one no challenge lah. Later we do a little bit more challenge one. Okay. Okay. So we are done on this. Yeah, I click save. Okay, never mind. Yeah, Those who come late just now, please scan this attendant, physical attendant, anyone? Okay. Now we move on to the last one already. I think no more already. After this one, okay, the last one, like I said, thyristor, right? There is another one called GTO. Okay, now the normal thyristor will only turn off when the polarity changes. Okay, the polarity changes or the what we call or disconnected. Okay, from the AC. So get turned off. Okay, it actually allowed you to turn on. Okay, the turn on is positive lah. Okay, and you can turn it off by applying a negative gate signal. Okay, so you no need to wait until the full cycle and only it turn off. Okay, so this is another type of thyristor that you can see commonly used. So all the device I show here, selected one is the commonly used one. Okay, in the power industry, a power electronic industry. Okay, so we are done already. Q&A for this what we call this chapter. Okay, any questions? So yeah, quite a lot of information, I know. Okay, please, drawing is important. Remember, drawing is important, circuit is important, equation important. Okay. Because your midterm will cover this entire chapter. Okay, so your midterm will cover the entire chapter of this. Even those in the Simulink, right? Okay, like this one, try to get yourself familiar with. Okay. Because now we are still in the midst of preparing the midterm. Okay, now we want to see how first, if midterm has to be conducted online, most probably like last time I will ask partly question you need to do the calculation, and there will be question on Simulink. Like I said, okay, please model this characteristic, whatever, using Simulink. Then you after you model, you screen capture your Simulink scope and the diagram. Okay, then that will be one of them, and then tell me what are the settings. Okay, so try not to do cheating in this way. I know it can be done, but it's easily for me to catch. You want to help a friend, right? You WhatsApp the model to your friend, right? And your friend just open. Remember, your friend don't know how to do. That's why he asked question. Please send me the answer for question 2, right? You are so friend with him, you without any thought you send. Do you think your friend will open up, modify, change a bit, man? No, right? He immediately cut and paste, pump. Now remember, why I said it's easier to catch. You look at all the diagram, all the class draw, can never be exactly the same, right? Can never be exactly the same. Once I spotted 2 exactly the same, I will just, okay, it depends. For me, I personally will just divide their mark by 2 . Okay, divide their mark by 2, meaning that okay, because I cannot know who is the original one. So let's say this guy gets 14 marks over 20 lah. So I will just divide by 2 lor. So both of them will get 7 mark lah. So yeah, you want to help your friend or your friend help you, please put some effort lah. Otherwise, like last time, look at it, I also want to laugh already. Okay, so basically we done this device. Okay, so now we should move on to the next chapter. Now, next chapter has been, I have been thinking for a while which one to start first. Like I said, power electronics, right? We have device, the rest is the 4 converter, 4 types of converter. We can actually start at any converter. It does not have any prerequisite, Once you know this 4, you can start. Okay, of course, when I do the notes, my original intention is start with DC-DC converter. Okay, then that's why DC video will have lots of information there. But after a while, because your assignment, okay, is going to be DC-AC converter. So to be fair to you guys, I think I will start with DC-AC converter. So that after Chinese New Year, all the class, right, it gets you all ready for your assignment. You may see some information missing, never mind. I will come back later, okay, through, the rest of the chapter lah. Okay. All right. So now we come to the first converter. Is DC to AC converter. Okay, like its name say. All right, it convert DC to AC. Okay, and then it is widely used in inverter. Okay, solar energy, the Tesla wall battery. Okay, that can convert the battery. Okay, the Tesla power wall, right? Okay, the battery. Okay, to supply your house. So this is what of my intention about your assignment to teach you all how to do this. Okay, simple single phase inverter powered by battery that you can use to power your house. And I think it's very relevant, right? Something very new and update It's not like something your grandfather technology, And then inverter also very important to me currently you ask me this 4 type of inverter DC and AC is the most, what we call is in the increasing trend. Why? Like I said, Tesla wall, okay, DC to AC. The grid, DC to AC. The electric car, also DC to AC, because the motor is AC The battery is DC, it's also DC to AC. And the solar farm out there that converts solar power connected to the grid is also DC to AC. So it is considered among these 4 converter, right? This has the highest trend nowadays and also have the most people doing research on it And even for this one, I already tried myself to put as much information as possible. It's already over 100 slides. I can't really squeeze more. Otherwise, I have no time for other converters. So what I'm trying to do is that to give you a better big picture. Okay, a better big picture that you will able to see, okay, the converters. If you want to learn more, okay, you can do it on your project already what I can say, okay, but should be good enough for you to do okay these converters. Okay, now for DC to AC converter, they are topologies. Okay, what is topologies? Now, topologies means circuit diagram, but we don't say circuit diagram. Or when we say, oh, what is the circuit diagram of amplifier? What is circuit diagram? Like I say, this is the language of electronic people. When you talk to power people, we don't use circuit. We call topology. So in other words, topology is a set of arrangements, okay, of switching device. So they even come with name. For example, push-pull topologies. If you buy an inverter, you can say, hey, this inverter, what topology you use? Then we'll say, this one, this guy know one, they cannot cheat him already. You know, you won't say, hey, what's the circuit looks like inside? Or they say, this one electronic guy next. Okay, so there are 4 types here: push-pull, half bridge, full bridge, and neutral point clamp. Okay, they are red color and black color, right? The red color, I'm going to go through with you in the class. Okay, the black color, really simply no time already. So at least you all know there is something called neutral point clamp. I will show you the diagram also. Okay. Now, they have modulation. Okay, they have modulation. Now, modulation basically only 2 types: SPWM and SVWM. Okay, so this modulation is to control the switching of the transistor, to modulate the sine wave in digital pulse, so that you can switch the transistor so that it can produce AC power to the load or to the grid. And the third one is control. In fact, this is the most complicated one, and it's still a lot of ongoing research. Now, all these converter, okay, they always have some form of control. Okay, they are voltage control, current control. You want to control its voltage, or you want to control its current, or you want to control both. Okay, you can actually control them. You see, the battery power wall is an example. You can control how much power this battery deliver to the load or deliver to the house, so that you can calculate in a way that it lasts longer lah. And there are second type is synchronous, okay, or stationary frame reference for active and reactive power control. For grid inverter, right, you can actually control how much real power and how much reactive power to the grid. And then remember, because grid itself, right, already got sine wave, right, and you are generating another sine wave, and then you want to put them together. Synchronization is very important because the sine wave have to go at the same time. Okay, if it's not overlapping, what happened? Your house circuit breaker will trip. Okay, or the inverter itself usually have a protection that if it does not synchronize, it trips. Okay, that's why you can never turn on your inverter lah. Your inverter cannot sync properly. So this one is what we call grid tie. And of course, we have another type of inverter is stand alone. That means it does not connect to any grid. You are building a system in the middle of nowhere, okay? And you need power, right? You can power by battery, you can power by solar, you can even power by wind energy. Okay, so there are inverters for that. And the last one is called islanded. Okay, islanded means that it is widely used in microgrid. Okay, microgrid consists of more than one source of energy, like wind turbine, solar, fuel cells. Okay, and then it is a cluster, okay, of inverter that work together as islanded. Okay, so this one we call islanding or islanded, okay, control. Now this islanded is important. Just imagine if your house, right, you have solar PV, you got inverter, power to your house. And then suddenly the TMP power cut off. But your PV does not have this islanded detection feature. You will never know that now grid no more power, right? If there are sun, you still continue power. Then what happened? Your next house do not have solar because they are connecting on the same line. They also got power, right? That is very dangerous. Okay. Because, okay, power cut off either is by short circuit or either is for maintenance. Okay, TMB guy will say, oh, we want to change something, we turn off the grid. Then they go out and they do the thing. But you have a solar there, and your grid, your inverter never know that at that point, it's called islanded already. Island is just like island surrounding water, no more power coming in. You are not connected to anyone, but you, your own, have power. Then the guy go and touch the live, of course, he got shot lah. That's why nowadays, okay, when you want to connect this using a house, right, you must use an inverter that can detect islanded feature. That means the inverter will have to confirm there are power from the grid first, before he develops power. Or else it will also trip himself, okay, for safety purposes. So a lot of things we can talk, okay, but this one I also exclude, okay, because the course outline just say DC to AC ma. And then like I say, I try to pick those common and important enough, okay, to do it. If you look at the textbook I show you just now, you warm it up. Okay, first topology. It's called push-pull topology, okay? Now, topology means that you can see, oh, this is a arrangement of the two MOSFET, okay, with a battery and a transformer with a center tap, okay, and connect to the load. Now, this is, if you want to use a push-pull topology, this is how you connect. So how we convert a DC to AC, okay? So this is how it works. First of all, you can see that, okay, this is a plus, minus, right? So you go through the center tap, plus, minus, come through here, and you turn on this transistor first. You turn on this transistor first. Then the transistor will pass the current back, right? So the secondary, it will induce the plus and minus to here. So this can be 12 volt, 12 volt battery, and it depends on how much you want to step up. You can step up to 230 using a transformer. Okay, then your transformer output will see the positive cycle. Okay, you will see a positive cycle. This is what we call the push cycle. It's a push-pull, push-pull. Okay, so in other words, this transistor at this point is a push cycle. Sorry, I can't write properly. And then when this one turn off, this one turn on, this is the pull cycle. Okay, this is the pull cycle. You can see now, again, the supply is here, right? But it go through, because here it's already off. So the plus is here, it go up there, come back, and go down here. And here you can see the positive, negative become opposite. Okay, to the secondary. So that is how you get the negative cycle. And this process repeat, push, pull, push, pull, push, pull. And along the time, you will actually see an AC output. Okay, AC alternating, right? Positive, negative, positive, negative. Very simple circuit, very old school, and it's still working nowadays. The cheapest inverter you can make yourself. A lot of these small handheld inverter, they are using this method. Okay, and of course, usually very low power, like 100 watt to 500 watt, the most. You know, those 1000 watt one usually need a very much more complicated circuit. Those very small one, okay, 100 watt to good enough to what we call power anything AC appliances that is less than 200 to 300 watt lah, depends. Okay. Okay, so the transformer will look something like that. You can really get this transformer from Jalan Pasar. Okay, Jalan Pasar now 12 volt. Now center tap 1 0 12. Okay, and it's 3 amp. Okay, it's 3 amp and the output is 230 watt. Okay. Now you can model this transformer using MATLAB. Okay. Now, how do you model? Okay, you get a linear transformer, okay, that had 2 winding, okay, or we call it 3 winding linear transformer. And then you can start to model it. For example, the VA, 36 VA, which is the power, 50 Hertz, okay, refer to here. All right, the winding 1 is 230, winding 2 is 12 volt. All right, and then of course later you connect them together, it becomes a center tap. It becomes this one, okay? It becomes this one, it becomes center tap. And the rest, okay, this one is a second winding also, because we got 2 12 watt here, right? 12 watt here and 12 watt here. This is how you, and then the one in the middle here is 0. So exactly the same here, the center tap. We call center tap, okay, technical term. And then, okay, this one you all no need to do. Go to this website and download. Okay, I have uploaded this one in MATLAB. Download this thing, okay, and then run this demo. Okay, run this demo, and you can see that the pulse here, okay, I put 50 Hertz because I want to generate 50 Hertz at the duty cycle of 50%. Okay. And then you will see that I put a NOT gate here. This is because remember, these two cannot be turned on at the same time. Okay, it's always one on, one off. That's why it's one push, one pull. You cannot two pull, two push. Okay, so that means when I have a positive here, and this one will be inverted lah. Okay, this one will be inverted. And you can see these are the same topologies and the same AC load. And after you run it, right, you will be able to see the waveform. I'm not sure I got the waveform here. I got the waveform of the current and the waveform of the voltage. Okay. Okay, try to do it now. I'll see if I have it here or not. Okay, it's here. Now we run it. Okay, can run. Now you notice I'm using the different component, right? Okay, all these components are actually using under Simscape electrical and also under the specialized power system. Okay, under the specialized power system. So you can see there is another block called power electronic. So this is the IGBT I use or MOSFET. Okay, so you double click, you will see the, yeah, you should be able to see this. Okay, now in my slide, you actually also see this one. Okay, this one. Okay, what is this? Okay, this is what we call the FFT, fast Fourier transform. I think you all study this in your numerical analysis. Fast Fourier transform, we can see every frequency component. Now, why is it very important to see this? Because even we already achieve AC, but there is a problem because for our understanding, our AC is a sinusoidal waveform, right? Beautiful. So meaning that they should not have any harmonic. Okay, but this one is square wave. It's like I say, good enough to power small, low power device. It won't cause much more problem. And for stand alone, you cannot connect this to the grid. You connect it straight away, TMB side will trip. Okay, so in order to know the harmonic, you need to use this FFT analysis tools. So you can see that, wow, the harmonic is so severe. It's 40%, THD, total harmonic distortion. If you want to design an inverter that can be connected to the grid, TNB mandated that your THD must be less than 5%. Okay, 5%, of course, on your eyes, almost no different than sine wave already. Okay, now, how to perform this? So to perform this is some technique you can use. Now, there is a power GUI here. You double click. You go to tools. And you go to FFT analysis. So FFT analysis, you wait for it to come out. This one take a bit of time. Okay. Well. Okay. Yeah, how to do this full screen already? Control 3 or wait. See, I cannot see this thing out there. It's blocking already because I need to do the. Oh my god. I think it's control. Full screen, full screen. Anyone can tell me what's the full screen? If your computer, because my screen is so small, then I will have this problem. I forgot already. Anyone know what is the shortcut key for the full screen? Window button up. Oh, very good. Okay, window button up. Okay, that's the full screen. Okay, so now you will see that, right? The red color, okay, it should cover at least one cycle. So you go to one cycle, 50 Hertz. Okay, this one, remember, change 50 Hertz. Once you change 50 Hertz, okay, and then, okay, the rest, then compute FFT. You click compute FFT. So you can see that now the horizontal axis is a frequency. 0, 50 Hertz is the highest. 100 Hertz, 150, 200, 250, 300. So these are what we call harmonic order. Okay, the third harmonic, fifth is odd number lah. You can see it's all odd number. Okay, these are all harmonic order. And you want to see it clearly is that you can see the THD here. The THD is 40.12. Okay, 40.12. And you want to change the order, right? You can change here, harmonic order. Okay. So here it shows frequency. So let's say I compute again. It should update to see? Okay, the number doesn't display is an odd number, right? 1, 5, 1, 3, 5, 7, and so forth. Okay. So don't worry about understanding this at the moment. Okay. What you all need to know is just the THD first. The THD. Okay, because this one got a lot of detail to explain. But at this stage, because it's still no sinusoids. So yeah. Okay, try to do this. See, how come it doesn't allow me to? I had to drag it down. Okay. So yeah, try to do this one. Okay.
Sir, our
Yes.
FFT, right, analyzer, right, it actually empty.
Oh, okay. If your one got empty, right, means that you need to, okay, those who have this empty thing, no waveform come out, right? Okay, you all need to go here, modeling, model setting. Okay. And then under this data import export, your ones, this one should be checked, right? There's a tick there. So uncheck it. Okay. Single simulation output. We don't want single simulation output. You uncheck it, click apply, click OK, run again this one. You need to run again. Okay, you need to run again, then you try again. You should be able to see the waveform.
Sir, mine is already unchecked, but then I still couldn't generate the FFT.
You need to run the whole.
No, mine wasn't checked at all since the beginning.
Wasn't checked.
Yeah.
Oh, that is strained already. Let's see how others are.
Okay. Same also, sir. Also same. Originally it's unchecked already.
Originally it's unchecked already. Very strange. I think nothing else already, only this one. Okay, can anyone in the class can tell me whether you all can see it or not? The rest, I don't think we need lah. Wait, let me see. Do I miss anything? I think I don't miss anything, right? Simscape, no, nothing. Okay, let's see how about the rest of the class. Okay, still cannot, Feng Chunwei. Okay, you all download this one already, right? Okay, if you use your own scope, if you use your own scope or you draw it yourself, you cannot see it. Okay, one of the reason is that you need to change this scope also lah. For if you are using your own scope, you draw yourself, you need for logging, you need to come to logging. Okay, you need to check this one, log data to workspace, and then select structure with time. Or else by default, right, the scope doesn't have this check. So the scope does this check means that the scope will only do display for you. It does not record the data in MATLAB. That's why the FFT open up, it cannot see the waveform. Try this one.
This is the problem.
You see, when I ask you all to download and use, download and use, don't be pandai, because there are a lot of secret setting inside you all don't know. Don't worry, you all still got opportunity. I got so many, this what we call model waiting for you all to create, okay? Because this one is a simple one. I really don't want to waste time asking you all to create. Okay, like I said, those inverter, right? 100 watt, okay, in real one, it looks something like that. 100 watt, okay, those you can use in the car. Okay, you buy this small piece of thing, right? You can plug inside your car and you can power up, charge your laptop or whatever, okay, or mini device. So most of these type of converter, right, okay, are using this push-pull, okay? Okay, so I think you all know the tricks already, important. Even is, yes. Which one? What graph? FFT. This one, right? Yeah, you guys sit nearer lah. So far, I cannot hear you. I need to shout. This one, right? Are you all talking about this one? Sorry? You still get empty. Wow. Like I said, you don't do any changes. Download the one I give you. You should get it. And then, okay, for those even you are downloading, right? You go to this model setting. Under this model setting, you need to do the data import, export. You uncheck this one. You need to uncheck this one. And you check the scope. If you are download direct for me, I already set the scope to log. Logging, log data to workspace. With these two set, right? Okay, you should be able to see it lah. Yeah, you have to make this work because the rest of the inverter, we are going to use a lot of this FFT. Okay. Oh my God. Yeah, K1, okay. Go, okay. Also have reopening model, okay. Uncheck, okay. Yeah, good. That's why you see, I like when you all do this in class. When some of you having problem, right? You see, some of your classmates will do screen capture and do this and then post it up to help each other. After the class, you always can see. Thank you, Tae Boon Hong. I really appreciate your effort in showing this to the class, okay? I hope the rest of us will do that. If everyone asking the same question after one and after 30 questions, 30 minutes gone already. Okay, so that is the purpose for you all to do the practice. All right. Okay, so I think wait okay, let me just summarize this. Okay, almost time already. Okay, the pro and cons of this type of small inverters. Okay, the pro is simple. Like I said, you can really go to Jalan Pasar, okay, buy 2 MOSFET and 1 transformer, okay, and a battery. That's all. You can create your own, okay, inverter already. All right, you can really make this a practical real inverter and can convert DC 12 watt to AC 230 watt. Good enough to power small device. Okay, remember small device. Bigger device we need to explain in the next class. And cons, what's the problem? Okay, the disadvantage. Of course, if you require higher power, right, and you require a bigger transformer means that heavier, okay, and expensive. And of course, the problem already show you all, the output is not pure sine wave, okay, it's square wave. So that result in a very high harmonic, okay, THD. And then square wave, okay, high harmonic voltage and current. So that is the con. All right. So, okay, that one, I think this one we will continue next class. Like I said, I know that it's Chinese New Year Eve, okay, next Monday. I hope lah. I know it's Chinese New Year Eve, somewhere at the time of 5 o'clock to 6:30, right? Reunion dinner, man. Okay, okay lah, you can go on, but please watch back the recorded video because, like I said, it's very important. Okay, the rest of them. Okay, so I felt that I'm going to be very lonely on Monday. Okay, alone in the class, 5 to 6, 6:30. After that, I have to rush home for my reunion dinner. Okay, like I said, you know, please watch back the video if those who really cannot even attend online. If those can attend online, I very much appreciate. Okay, all right. Any questions? No question? Okay, no question. Then we will end the class today.